Okay, right. Talking about rotating in the last video of textures, this time we're going to be looking at rotating of the object, RotateAboutAxis. Now we're using again some input data that we haven't covered yet, but let's do that. There we go. But we'll cover those later in the sort of input data section. So RotateAboutAxis, what is it doing? Well, it takes a input, in this case our object position, our object pivot, an angle to rotate around or an axis to rotate around, and then time, and it creates the correct offsets for the world position offset to rotate the object, as we can see here. It is very useful for doing this kind of rotational motion. One thing it doesn't do is actually update the normals. So you might sometimes get some lighting errors with this. There is a RotateAboutAxis fixed RotateAboutAxis normals, and you can plug in the same information in here and get the normal information out of it. Tends to be that if you're doing that and you want to have a full rotating object, you might be better off just rotating the object itself, rotating a static mesh in blueprints. This kind of rotate option here is very useful for doing kind of small subtle movements where the updated normals aren't quite so important. So cloth, foliage, that kind of thing. We haven't covered the transform node yet, but we will do shortly. What this does is it changes things from one space to another. So here our rotation axis is in the blue axis, is in Z, and if I take my example here, and just make a copy and rotate it, let's say 90 degrees this way, you can see it's rotating around that z-axis still. So the world up axis is the one being rotated around, and that's fine, that might be what we want. But if we want the rotation axis to always be the top of the sphere, we need to change our transform, or we need to change our axis. So if we transform this from local space to world space, and then normalize it, what we should get is no difference at all in this window, because the world up and the local up are the same. I mentioned right at the start, looking at the preview window, that sometimes you get errors. Well, this is kind of one of those errors where it doesn't matter whether they're using local or world up here, because they're the same direction. But if I apply this and let it compile, what we now see is it doesn't matter how I rotate my sphere, it's always rotating around that local axis. So really nice feature to have. As I say, quite useful. Not perfect. It's only a sort of a visual preview, but can be useful for little animations and that kind of thing. Okay, I guess while we're talking about transforms, there is a material for transform, wherever it is. Oh, in fact, it's the next one. Let's just do that. There are two transform nodes, transform vector and transform position, and it moves things from one space to another. And when I say space, what we're talking about here is a coordinate system. So world space, we have, if I just create a new object, let's just create a cube, and then if I zero this out, so this position here is 0, 0, 0 in world space, and then as we move this around, it's moving in world space. We're getting that that value there. If I were to, let's say, scale this up slightly, now if I wanted to, I've rotated my cube, and if I wanted to move it along its newly rotated axis, I can't do that with this gizmo because it's not aligned. But up here we have the option to cycle between local space and world space. So now as I rotate my cube, its local space stays sort of rotated with it, but world space is different, and you can see that here, and that's what this gizmo does here, or this button here option swaps between world space and local space. And that's what we're doing in material. So we're changing our coordinate system. There is also, if I jump back to the example, tangent space. So tangent space is effectively local space for every face, and so is useful for calculating lighting calculations. So normals are done in tangent space. There's also view space. View space isn't going to have anything in here. No, not so useful, but that's to do with how the camera is sort of pointing. And then you have camera space, instance particle space, all these different ways of sort of defining things and calculating our values. When it comes up, we'll use them. Can be a little bit tricky calculating the different things. But here we've got the blue axis, or the away axis. In world space, that's just up, and then if we were to convert that, the up axis of every face is now what we're looking at here, so the tangent space. So which way is the face facing? So here, this face here is facing the red axis, and so that gives us our world direction. And you can see, so rather than just using the blue as a color, we're converting the faces up axis, or the faces normal axis, into a world space, and that gives us this view here. And the same can happen with position as well. So we have local space, world space, view space, etc. Okay, something that will come up, and we'll use it in the examples, but they exist here, the transform nodes, and then an example where we can use them, changing this up axis. So the up axis is either world aligned, or the world up, or we can transform it from local to world, and we'll get the local axis, and we'll get our sphere rotating around the local axis instead. Okay.